over non-rectangular regions. So, oops, I think I'll start with this one, which is a kind of standard one. Double integral over a region D. This is the function dA, and dA is going to be dx dy or dy dx. It's differentiating. It's a differential over an area. In this case, the region's explained to us, so we really don't have any choice. The x is going to go from 0 to 7. And the y is going to go from 0 to square root of x. And just remind you, you don't need these x's and y's, but I like putting them in. It's up to you whether you want to or not. Let's start you off with a nice simple question. Dx dy or dy dx? There's only one that's correct. Dx dy, dy dx. Who's first? Who's second?
dy.
And there's not really a choice there, would you agree? I put a little bracket in for emphasis. Can you see the x's match with the x's and the y's match with the y's? So it's going to be this guy. Well, integrating is like partial integration, right? The only guy in town that's a variable is y. Any other layer, in this case x squared plus 1, is considered a constant. Now, I know that looks like a fraction. Well, it is a fraction. And you might think that that is going to interfere with the answer. But in fact, the antiderivative of that isn't anything really that special. Isn't it just a power rule over x squared plus 1?
Yeah.
Agreed? And then we're going to evaluate it from y equals 0 to y equals the square of x. And if you plug in the square of x here, you get 1/2 x over x squared plus 1. And if you plug in 0, you get 0. So I'm not going to write take away 0, right? Dx. And in a lot of these questions, to save time, unless it's something special, I'm probably going to leave it at this stage. Would you agree that this is just a Calc 2 integral? And the technique for solving it would be what? How would I find this integral?
A u-sub?
A u-sub.
I agree.
And the u-sub is that, right? So dot, dot, dot. You finish that off, right, when you want to. Are we good with that? Now, if they give me the information written in that form, I really don't have a choice, right? I have to do what they tell me. Agreed? So let's look at this fella over here. It's similar to question 7. So double integral over a region D. The function is not that big, it's x, differential A. The region D is enclosed by these lines. So we have a line called y equals x, which is going to be this line. Looks very familiar. Y, oh, have I done this one? It looks very, very familiar. Do you recognize this question? If I've done it, then I guess I shouldn't do it a second time. Does it look different enough? I may have just done one similar, in which case I'll still do this one. Does anyone recognize this or not?
I recognize from trying to do it on homework, but I don't recognize it from an example in class.
Okay, that's all I need to hear. Right, so y equals x, done. Y equals 0. Well, y equals 0 is actually the x-axis, isn't it? No, that's a bad color. Is the x-axis. And x equals 2 is this line here. So the region that we are trying the D, if you like, that we're going to integrate over, is this guy. And question E introduces a terminology that's new. It asks us to express this region as a type 1 region. Essentially, a type 1 region is one where the x's are numbers and you express the y's in terms of x's. So in a type 1 region, we would call D this fella, set of all points x, y, such that x goes from 0 to 2. So in a type 1 region, the x's are numbers and the y is in terms of x. So can you imagine my little vertical rectangle scanning across? If I randomly pick there, the y value at the bottom is 0 and the y value at the top is a straight line. So the y value at the bottom was 0 and the y value at the top was the straight line y equals x. And that is the type 1 version of this region. So far, so good? Right, now, you can imagine then what a type 2 region is. In a type 2 region, we have the same picture, but in a type 2 region, the y's are numbers. And I'm going to put in a little dotted line here, put in a 2 there, and remind myself the equation of that line. So in this case, the y's go from 0 to 2. And the x's well, they go from here to here. Here is called x equals y. And the end is x equals 2. I don't know why that turned into blue. So this region, this same region, because it's still D, so still the same rectangle as before, if we imagine that we're doing it from y equals 0 all the way up to y equals 2, then the x values go from a big number 2 to that point, and that point we give in terms of y. Are we comfortable with the type 1? Type 2. Now, we did talk yesterday about you can create, not yesterday, on Friday, that for a given region, isn't there 2 different ways you could approach it? You could describe it this way, or you could describe it that way. And in a lot of questions, it won't matter. The amount of work to get the answer will be about the same, so nobody really cares. In some situations, although both are possible, right, you can get the answer, one of them might be a lot less work than the other. And then the third situation is, one of these allows you to get an integral that's doable, and the other one doesn't even have a fighting chance of being correct, right? So it is a skill that we want to be able to incorporate. Now, what you're meant to do in the rest of this question, I'm trying to think, was it Brooke, was it you who said you tried it and had trouble with this?
Yeah, it didn't really make sense with the type 1 and type 2 region. So I tried another example and it helped me. And then it told you to solve both of them to make sure you got the same answer. So you have to solve both of them.
I don't, right, have I made it even more complicated, or does this help simplify your mind?
Oh, it does. It helps a lot because they do not say what type 1 is in express y's in terms of x. I had to use an example and watch the video, and they didn't even identify it as type 1 in terms of y, express y's in terms of x, or express x in terms of y's for type 2.
They just said here's a type 1, but didn't tell you why it was called type 1?
Correct.
That's not very nice of them. Okay, both of these are the same region. So both of these are going to give me the same answer, which you will discover, but I don't want you to spend time doing both of them. So do you want me to do the type 1 or do you want me to do the type 2 just to show you the full process on this very simple
Type
integral?
2, I had a struggle trying to do type 2.
Okay, so we're going to do a double integral. The y's are going to go from 0 to 2, so they go on the outside. And the x's are going to go from y on the small side to 2 on the big side. The guy's x, it's pretty obvious that the x's come first, so dx, and then the y's come second. Are we happy about this would be the double integral using a type 2? You comfortable
Yes.
about where I put the y's, where I put the x's, and the
Yes.
order, right? So do my little bracket thing just to emphasize it. Y equals 0 to y equals 2. X is not the hardest one in the world to integrate. We're going to do it from x equals y to x equals 2. If you plug in 2 here, you get 4. Half of 4 gets you 2. If you plug in y here, you get take away a half y squared. You get to here. And this one's so easy, I might as well just finish it. That's going to get you 2y. That's going to get you add 1 to the power and divide by the new power. A bit messy. From y equals 0 to 2. If you plug in 2, you get 4. If you plug in 2 here, you get 8/6. Take away nothing. Oh, who cares, right? Turn that into 24. 24 take away 8 is 16. 16/6, which of course is 8/3, and that's your answer. Now, if I'd done the other one, this top one, I would also get 8/3. Agreed?
Yes, makes a lot more sense than what I tried to do.
Well, you know, textbooks are sometimes hit and miss. Either they overwhelm you with knowledge that doesn't help you to answer the question because they get into the details of the proof of why it works and the general version of it, or they miss so many bits out that it's kind of easy to get lost. It's a bit like going on a trail where half the signposts are missing. So you keep hitting these left and right forks, but you don't know which one you've got to go because they don't give you any clues, right? Because I've already jumped on to the next part of the trail and you're trying to think, what should I do? Are we good with that question? Any questions about it? I'm moving on if there's not. Okay. Let's see what I can find. Oh, I didn't notice this one when I was doing my scan this morning. I wish I had. That's the double integral. The region D is bounded by y equals x take away 42 and x equals y squared. And we're being asked to find this double integral, and they say using the easiest order. So we know that we can do in 2 different directions, right? So let me see, y equals x minus 42. Can you pretend that I went into Desmos and it looked like that, right? And the second piece of the puzzle is x equals y squared. And can you imagine that I found this region with Desmos? I know I didn't do it, but can you pretend I did? That's what it would look like. Does that seem reasonable, right? So I know what I'm looking for, the area enclosed by those two, which is this fella here. And they're talking about finding this particular double integral, but doesn't that mean first I need to describe region D in terms of limits on the x's, right? The x starts from here to here and y starts from here to here. Now I have two directions I can go. I can do the vertical, I can do the horizontal. They talk about the one that's easiest to do. And this one is going to be even easier than that, because only one of those two, because I can see it happening, is actually even going to have a chance of working. And let's show you why. Let's suppose that I try and do vertical, right? Now, if I do a vertical here, and I'll just do it as a line, it's fine. But what happens when I get to here? Do you see that my vertical line is on the same curve? Shouldn't the vertical lines be one from one curve and the other half, right? The top from one curve and the bottom from the other curve, right? As it would be here. If ever you have a vertical line and it's the same curve, in this case x equals y squared, you can't do the vertical, right? It ain't going to happen, right? I mean, in fact, how could you even describe that region? You're not even taking into account this guy, right? So it doesn't really work well. So for that argument, that direction doesn't work, I'm going to go this direction. Now, when you go horizontal, don't you do the y values as numbers, and they're going to start here, and they're going to finish here. So the region D is going to be all the values of x, and y is going to start and finish at a number. Okay, now if I had Desmos here, couldn't I just put my little mouse point and dot on it and it would tell me? You agree? I mean, I could go in Desmos and find that. So you're going to, again, have to just trust me here. This particular one is 7 and 6. I know it's 7 and 6, so I'm not even worried about who it should be. Let's see if I make it -7. So that's going to be the 7, and this is going to be -6. Can you just trust me that you can find the y coordinates of those intersection points? Now, if you don't trust me, which is totally fine, if I say that guy is equal to this guy, then if I replace the x with y squared, don't I end up solving that guy? And can you see my 7 and my -6? Does that help? So I could have done it algebraically. So I know that the y values go from -6 to 7. What about the x values? Well, it goes from the straight line, that's the big guy, to the curve, which is the small guy. So the big guy goes here, right, and the small guy is going to go here. The big guy is this fella. Oh, well, yeah, it is, but that's not the version I need. I need to rearrange this guy to be that guy. And what about the little fella? Oh, perfect. So I'm going to do a double integral from y equals -6 to 7. From x equals on the small side, y squared, and on the big side, y add 42. The function is going to be y. It's going to go dx dy. Are you happy about my d and my integral setup? Is there anything, how did you do that, or how did you become that you want me to go into? Straight line to curve. Straight line to curve. Okay, now in this particular case, brackets for emphasis, It's going to be the integral from -6 to 7. If you integrate this guy with respect to x, that becomes xy. And that becomes, well, if you plug in y for x, you get y plus 42, take away a y cubed dy. Okay, there's a little bit more work to do here, but I'm going to stop here. Wouldn't you distribute this and then just integrate a polynomial in terms of, y? So it would be a Calc 2 question, and basically power rules, adding 1 to the power and dividing by that new power. Dot, dot, dot. Are we good? Any questions? You are allowed to ask questions, and I promise I'll only make fun of you a couple of times and laugh at you the rest. No? Okay. I guess things are going smoothly then.
Professor?
Yes.
Actually, I do have one question.
Great. What you got?
Why is the lower bound of the integral on x y squared?
Okay. When you do a horizontal rectangle, the guy that's furthest to the right is considered the biggest x value. And the one that's, well, if that's biggest on the right, the one that's next to it, that's considered the smallest. So when you do integrals, don't you always do the big guy on one side and the small guy on the other? So when you do horizontal, the one furthest to the right is the big one, and the one that's not is the small one. And that's, and you can think about that. Isn't that got a bigger x value? Isn't that further along in the x-axis than this one here is? So more to the right is big. When you do it vertically, you don't think about it because it's kind of obvious. Isn't the highest up one the big guy, and the one below that the small guy, right? Vertically, it's a little bit easier to see. But horizontally, I mean, if I did that, big, small. Does that help?
Yes, thank you.
Okay. So move on. Nothing to see here. Okay. Next one. Oops. It's going to be like question on 11. I'm going to do double root thingy over d 8xy. And D is a triangular region that uses the points 0, 1, 1, 2, and 4, 1. So I'm going to try and plot these points. 0, 1 is here. 1, 2 is here. And 4, 1 is here. Okay, so I've got my region D. I do have some issues. It's quite a big issue. Don't I need to figure out how to write D so that it looks like this guy? Right? I have to describe this region D in such a way. Now, you got a region. You can either go vertical rectangles, you can go horizontal rectangles. Sometimes both work, not this time. In this case, only one of those directions is actually going to generate something that I can use easily. So let's see what's wrong. So this is one I'm not going to pick. Let's see what's wrong with the vertical rectangles. I'm going to use my pen here. Can you imagine my vertical rectangle being here? Nothing wrong with that. Don't I have a line and another line, right? Now, as I scan from left to right, when I get to here, isn't this a different rectangle? Because it's a different top line than this one. Do you see that doesn't lend itself then to a single interval? I guess I could split the shape into two and do two separate integrals, but that seems an awful lot of work, and we're trying to reduce our work, not increase it. So my argument here is vertical orientation, right? Vertical lines are not going to cut it. Let's see what's good about horizontal. I know my picture's getting really messy now, but there. Won't a horizontal one have this line on one side and this line on the other? Not only that, if you do a horizontal one, won't the y values, because you imagine me scanning from the bottom to the top, won't the y values be quite easy to detect? Won't the y value horizontally go from 1, scan up, and finish at 2? Now, I have an x boundary. Now, won't this line here be the big value of x, and won't this other line be the small value? But won't both of these lines have to be written in terms of y, right? So now we have a side job. I need to find the equation of a line that passes through the point 1, 2 and finishes up on the point 4, 1. And I need to find the equation of that line. And once I do get its equation, let's say it's 2x plus 1, right? Y equals 2x plus 1. Won't I then rearrange that equation to x equals a half y minus half, or whatever form? So here's a bit of math you probably haven't seen for ages. How do you find the equation of a line passing through 2 points?
Y minus y1 equals m times quantity x minus x1.
Which is very often called the point slope equation. x1, y1 represents either of these 2 points. So you get the same equation, so that's not a problem. So I'm going to call this one x1, y1, and I'm going to call this guy x2, y2. So right now I have got y take away 2 equals the slope that I don't know yet, x take away 1. So here's another equation for you. How do you find the slope, because that's what m represents, the slope joining 2 points?
Rise over run, y2 minus y1 over x1 minus x2.
Yep. You all comfortable with that guy? Rise over run if you don't like all the y's in here. So in this case, it's going to be 1 take away 2 on the top and 4 take away 1 on the bottom, which I believe is negative a third. Are we good so far? Now, the next few lines are really just make things look pretty, right? Style points. And there are a couple of approaches to this. I'm just going to go the boring way. Distribute the 1/3. Subtract 1/3. Multiply everybody by -3. Have you noticed that I have not created the equation of the line in its standard y equals form, but I've created the line in its x equals function of y form? Why am I writing it in this form rather than the typical way that you would write the equation of a line?
Because you want it in terms of x. You want it in x in terms of y's for the equation.
Because we're going horizontally, right?
So, exactly. So, have you noticed that that's the equation of the line, but this version is what we need. Now, on the other side, I need it to go from the point 0, 1 to the point 1, 2. And the slope of this line, rise over run, let's see what that is. That's a 2 take away a 1 over a 1 take away a 0. Well, that's just 2. That's fine. And then the point slope equation. I'll use this guy, so it's going to be y take away 1 equals 2 x take away nothing.
Isn't
y
2
take
take
away
away 1
Whoops.
divided by 1, 1? 2 take away 1 divided by 1 should be 1.
Oh, good. You all catch that deliberate mistake. Yes. Oh, actually, we got kind of lucky with that one, didn't we? We didn't really need to do anywhere near as much algebra. And so this double integral will go from y equals 1 to 2, from x equals y minus 1 to x equals negative 3y plus 7 of 8xy. Do the x's first, do the y second. Okay, let's see if we can take this just a little bit further. If you integrate 8xy with respect to x, what will you get?
Or x squared y.
Okay, we're getting to the messy part here. Can you trust me that if you plug x in here, you'll get an ugly cubic? And if you plug x in here, you'll get another different ugly cubic. So you're still going to have to FOIL some stuff out and collect like terms. But when you are finished, you will have an integral from 1 to 2 of, I don't know what the answer is, but you know, a polynomial with some, at least y cubes, probably y squareds, y and a number in it, right, all the way to the end. And then at this point, it's just power rule again. This just takes time. It's not difficult to do, I don't think. I think you just have to be careful, which you know I'm not, but you have to be. And so we can imagine 4 negative 3y plus 7 squared times y, take away 4 lots of y minus 1 bracket squared times y, you know, foiling it out, collecting like terms, and then you're finished. Are we good? Any questions? We are good. I like that. Before I leave, I've said this lots of times, but every time it happens, I like to say it again. Have you noticed that a piece of math that you've probably never used forever was necessary to do this question? In this case, how to find the equation of a line passing through 2 points. Nothing that you've done in math from Math 94 onwards is obsolete. You'd be surprised the little things that they throw upon you. Does everybody here know the quadratic formula? Without looking it up.
I do.
Well done. You know, 4
I know.
years from now, you're going to get if you do enough math, you're going to do an upper level question, and you're suddenly going to have to use the quadratic formula. It's a piece of knowledge that you never use for months or years, and then you need it. So hopefully you keep that in mind whenever you're doing stuff. Okay. So what are we on to next? Well, we're on to finding volumes.
Is this 15.3 now?
No, we're still on double integrals over non-rectangular regions, and we're just finding an application. Why would you want to find a double integral? Well, one of the reasons would be to find the volume of some shape. Now, Imagine that you have, I don't know, some triangular region, right? That's your D, right? And then you've got some curved surface. That's your Z equals function of X and Y. And this fella goes up and he hits here, and this guy goes up and he hits here, and this guy goes up and he hits here, and you end up with, I can visualize this a lot better. I wish I was an artist, it would be a great combination. But can you imagine this Toblerone shape going up and meeting a surface? That solid shape there, its volume is equal to the double integral over d of f of xy dA. Right? So you want to know the volume of a shape, you need to know equation of the surface, because that goes here. And then also, don't you need to know how to describe region D in terms of a type 1 or type 2? Right. X goes from 1 to 3, Y goes from function X, function Y, right? That kind of thing. Or horizontally, whichever one generates the least amount of work. So suppose that the surface that you have is a plane. So this is like question 12. And the equation of the plane is 9x plus 2y take away z equals 0. And the region, although they're not calling it region D, I am. And the region D is described by the boundary of y equals x squared and x equals y squared. We are being asked to find the volume of the solid that is generated by this plane meeting up with this region, right? Okay. Now, sketch it. Probably use Desmos, but I can get away with it. Looks like that. That's what y equals x squared looks like. X equals y squared looks like that. Again, Desmos can do the whole thing. Are we okay with me just pretending I did Desmos and trusting me that that's the shape D? Now I want to build up what D is. In this question, can I do vertical? Can I do horizontal? Both will work. Would you agree?
Yes.
So,
Yes.
so being a boring person, I'm going to keep the x's, right, as the numbers. So essentially, I'm going to do a vertical one, right? Now, for me to do that, don't I know where x starts? But even more than that, don't I need to know what value of x is here? Now, if Desmos was here, couldn't I click on the intersection point? Can you trust me that it's 1? Does that seem reasonable? So I know the x's go from 0 to 1. Now, the y's, that's the big guy, right? That's the small guy. Isn't the big guy the red curve? But the red curve is written as x equals y squared, which is not what I need. Don't I need y equals the square root of x? Agreed? Now, why did I pick the positive? Because technically, to get from here to here, I'd have to take the square root of both sides, because there could have been a negative square root of x as well. Why did I choose only the positive?
Because the diagram shows that it only intercepts in the positive.
That's it. And that's the big guy, right? That's the big guy. And isn't the small guy the bottom? And the bottom one is y equals x squared. Are you comfortable about how this became D? Can you follow drawing the picture,
Yes.
finding out where they intersect, and creating x's with numbers and y's in terms of x, what they call a type 1? We're good? Now, there was a second part to my puzzle. Don't I need to know what the surface is, f of xy? And which means I have to write this down as z is a function of xy. They didn't quite give me in the form that I want, but are you happy where that came from? How this became that? Are we good? Do you need any explanation, or is it obvious what I did?
I'd say it's pretty obvious.
Okay, then I'm cool to move on. So x is going to go from 0 to 1, and y is going to go from low to big. The function of xy is basically 9x plus 2y. Do the y's first, and then do the x's. And at this point, I'm doing another dot, dot, dot. I mean, once I've set up the double integral like this, hopefully by this time when you've done your homework, hopefully you'll have got enough practice that that becomes kind of routine. Which is pretty much power rules and plugging in, substitution, and then some more power rules. Are we good? Right. Move on. We're getting close to the end. Nothing that one I think causes trouble. 14's a triangle, don't need to worry about that. 15's another triangle. Here's one. Okay. We're being asked to find that double integral by reversing the order of integration. And I'm pretty sure the reason they asked us to do that is that if you try and integrate 13e to the x squared with respect to x, can you trust me that you can't do it? Algebraically, it doesn't have a solution. Right? There's not a use sum in the world that'll save you. Unfortunately, changing the order of integration does require a fair amount of work. So here goes. I'm going to create this picture based on these limits. Now I put in x equals 3y and x equals 12. Now if I tell you x equals 3y, can you just rearrange that to y equals a third x? And so can you imagine, there you go. That's what x equals 3y looks like, which is the same thing as y equals 1/3 x. Now, what does x equals 12 look like? X equals 12 is that vertical line. Y equals 0 is here, and y equals 4 is actually here. You can check it out. 1/3 of 12 is 4, so this guy up here is 4. So the region that is being described here is that triangle. And I created it by using these two guys and these two guys. Now, this particular region has the y's as numbers and the x's in terms of y. If I want to switch the order round, don't I want the y's to go here and the x's to go here, right? And the 13 e to the x squared, and switch places again, right?
You would want the y's on the inside, not
Yeah,
the x's.
Yes, I just knew that, but you're right. Yeah. So the only guy I really need to figure out here is how to describe this region in a different way. They've actually described this region going that way. So I'm going to describe it going this way. So x goes from 0 to 12, and y goes from 0 to the straight line, 1/3 x. And that fella is the new integral with the order switched. And you might think, big deal, it looks pretty much like the original. Not quite. If you do this integral, don't you get 13y e to the x squared? Right? If you integrate this with respect to y, don't you get 13y e to the x squared? Won't that y become 1/3 x? So what you'll end up with is some multiple of x e to the x squared, but that is doable. That will be a u-sub. So this is not doable. You switch the order of integration, and now the answer, because it's the same question, right? Just two ways of writing it. The answer is doable, and you can get the answer. So what am I getting at here? Do you see the advantage of having the ability to choose the order, whether you'll do it type 1 or type 2? And let's say hi, and that's time for today. And did we learn some cool stuff or not?
We did.
We did. I got a nod off you. I appreciate that, Vince. I get that knowledge nod. Like, yeah, that was some cool stuff there. Right? One of the sad things that's kind of sad is that the only people who would appreciate what we've done here, so if you were talking to some of your students, your friends or students, and say, "Hey, we learned some really cool stuff about switching from type 1 to type 2 double integrals in non-rectangular regions," unless they've done Calc 4 or beyond, won't the answer be, "I don't know what you're talking about"?
I get that all the time from my boyfriend.
I don't know what you're talking about, right?
Yeah, he does.
You know, we're in a little. I don't know what the percentage is, but let's say 10% of Americans have a math bent that they're capable of doing Calc 4. But of that 10% of Americans, only about 1% out of that 10 has probably done it. So there's only maybe 3 million Americans who actually know what the heck we've just been doing. You're in a small, very isolated group that you know stuff that nobody else has a clue what you're talking about. And that's kind of makes me feel arrogant now, you know. We're part of the elite now, right? And you've still got some really cool stuff that maybe only 0.5% of Americans will know. If you keep going through your math career, you'll learn some really phenomenally weird stuff. It's like a little secret society that we keep all this stuff to ourselves. Right, I've ranted on. Have a nice time, everybody. I'll hang about in case there's a question that you may have, homework or whatever. Otherwise, I'll see you tomorrow. Lindsay, was that not cool stuff we did?
I enjoyed it.
It's just so much fun. You were saying?
Like it.
Professor, I have a couple questions.
Sure, let's get started. What you got?
So I was hoping to go over the few things that I got wrong on go over my test. The other thing
Okay.
is that
hmm,
tomorrow I won't be able to attend class. They have me doing some field work tomorrow.
Okay, so you're going to
so
just
I'll
watch the video. Right.
Yeah. I just didn't know
Okay.
for like the participation if there's a way to make up the points or whatnot.
Nah, it's kind of is what it is. Unfortunately, it's just to keep it simple.
Okay.
I don't want to start making up decisions like I like your reason, Brooke, but I don't like John's. You know, I don't want to be an arbiter, so
Okay.
it's a bit painful. But you know, so you get 93% instead of 100%. I don't think it's going to kill your grade. And if you've already done the extra credit thing, it'll probably make up for that. So it won't matter.
Okay.
Okay. So your stuff is about your test, and I have no problems with that, but you might not want to share it with other people. So if I can maybe do other people's stuff first, like homework questions, and then we can do that after that.
Okay.
Right, Lindsay,
That
you got a
sounds good.
homework question, or are you in the same boat? You want to go over the test? In which case, I'll just have to do a test.
I have a homework question I've tried a couple times, and I've got it wrong both times, and by now I'm just like, I want someone else to look at what I'm doing and tell me if I'm making a really obvious error. Do you mind if I share my screen?
What's the question?
It is 15.1, number 5. I can share my screen and scratch it out if you like.
Perfect. That will be a good one. Do you mind other people seeing it?
Nope, no problem.
Nope, great. Hey, it's good, Brooke. You might see something that will save you some time when you come to do this question. All right, go for it.
Okay. Right. So it is 36 to 1, 6 to 1, and it is x over y plus y over x dy.
Oh, okay.
So when I've started this, we're integrating with respect to y first. So what I've done is x ln of y for the first one.
Looks good.
Yep. Plus 1/2 y squared over x.
Looks good again.
Okay.
You haven't done anything wrong there.
Okay, good. And then I guess, so I need to substitute in for y. I know it's going to be x ln of 6 and 36 halves over x minus, with 1 in there, that x ln of y is going to zero out.
Yep.
And then it's going to be 36 halves x. Wait, no, it's not. It's going to be, this is not the mistake I made, but so it is 1.
Yeah, you're just doing a different mistake. Not that I've ever made a mistake.
Don't need that anymore. Putting that in.
Okay, let's just tidy this up a little bit before we move on.
So x ln of 6 is fine, and that becomes plus 35 over 2x. Yep.
Perfect. Like it.
And then integrating with respect to x, that's going to be ln of 6 over 2 x squared.
Yep, that's fine.
And 35 halves ln of x. Yeah.
Looks good to me.
36 to 1.
Right, hold on a second. I wonder if your error, calling it an error, I'm not sure I should it now, is not that you've done it wrong, but the way the style points of what WebAssign was wanting is maybe not what you're writing. So your answer may be correct, but it could be a style point issue, right? So anyway, keep going. We'll see what your style points look like.
Yeah, I've inputted a couple different ways by now, and that possibility crossed my mind. So 36 squared over 2 becomes 648 ln of 6.
I'll take your word for it.
And then that becomes plus 35 halves ln 36 minus, that's going to be ln 6/2, and the second term is going to 0 out. Yeah, because ln of 1 would
Okay.
be 0. So
There's not an awful lot you can do with this. Let me just check one thing in my brain here. Do you know that 36 in the middle term? So don't take the 648, which is what you're about to do. So could you rub that out and I'll tell you what I would have chosen instead.
I know
Right.
that we can make the
Okay.
fraction a power and then square root it.
Right. So what's going to happen is that you're going to have 648 log 6. Just leave it alone for a few moments, right? So if you could write that down, 648 log 6.
Gotcha.
The 35/2 log 6 becomes 35 square root of 36, which becomes 35 log 6. So add 35 log 6. Take away a half of log 6. Now, what you're going to get here is just some fraction log 6. So it's going to be a really ugly fraction. It'll have halves as its bottom term, log 6. And that, I think, is what it was probably looking for as style points. Did you do a version that looked like that?
No, I did not try it out that way. And that could very well be it.
I did this problem over the weekend. I finished 15.1, and I had the same issue as you, Lindsay. And so I did what it says, practice another. And I went through and I looked at how they answered it, and then I solved the next one with respect to how they had it for style points.
It's so
And when they said style points, did it end up being what I just said, some ugly combination of log 6s?
Correct.
Yeah. So that just, you were bang on. I mean,
okay. Yeah, I just
it's being
check to make
nitpicky.
sure
Yeah.
something I hadn't missed something conceptual that was, screwing me up.
Yeah. You nailed it conceptually. It was just the bit at the end where, there's, I don't know. I don't have control of our website.
Yeah. Mine, I ended up with like 39 natural log of 4 over, it was like 39 halves natural log of 4 is what I ended up with.
Right.
Well, that's good to know.
And this one's going to be the same kind of looking.
I'm going to stop my share and try putting it in that way, and we'll just see what happens.
Okay.
Perfect. Thanks. Going to hang out for a couple of minutes, and hopefully that one's going to work for me.
Okay, G, have you got a homework question while she's doing
yes,
that?
I do. Mine, actually, I finished all my homework except just one. It's relevant to 15.1. So the question.
Just read it out. I think I'll probably be the quickest, and I'll put it on the white screen.
So the question is find the volume of a solid in the first octant.
Okay, the first octant is important. I can tell you that right now.
What messed me up a little bit there. So in the first octant, bounded by the parabolic cylinder, z is equal to 16 minus x squared. And the plane x is equal to 2.
Okay, so what you're going to look at here is a double integral.
Correct.
When you do z equals, what question number is this? Because I'm getting a little bit
14 on
confused.
15.1.
Right, essentially, let me tell you what the first octant is about. The first octant is here. It's the only place where the x, the y, and the z are all positive.
Okay.
Now, when you take this guy onto the xy plane, right? When you project this guy onto the xy plane, essentially what you're creating here, and I'm a little bit confused about where the y is, but I'm going to look at that in a minute, is that if you look at when does this equal 0, you get plus or minus 4. So it tells me x is 4, and then that guy tells me x is 2. And I need a y, but I'm assuming that it's going to be the z guy, which is this fella. And I now know that x is equal to 2 and x equals 4. I still don't know what the y's are. It sounds to me like there's something missing. Because what I'm going to have is a little rectangle here. And the x's are going to go from 2 to 4, and the y's are going to go from somewhere to somewhere. But as far as I can see, you haven't given me anything that would lead me to figuring out what those y values are. So I'm going to go in and have a look
I think
at their
that
solution.
I think the x
Oh.
equals 2 should be y equals 2.
Yeah, sorry, you're right.
Well, now
Sorry,
I
you're
have
right.
my answer, because my rectangle, this is going to tell me x equals 4, right?
May I
And
please see the
x
screen?
equals 0, and this is y equals 2, and this extra bit is because it's in the first quadrant. So it's going to go from 0.
We
Nope,
can't
it's
see your
going to be this
screen.
guy. Oh,
We can't see the screen.
I will put it back on. Right. So now we're good. This guy allowed me to find out what x is for, because I basically said, okay, when this thing hits the floor, right, the
Okay.
xy plane, z is 0. And when z is 0, x is plus or minus 4. But because you're in the first quadrant, you're 4. And
Okay.
you must be 0 to 4. And then the y is 2, and you must be in the first quadrant, so it's 0 to 2. So, and then I can do the rest. Now, pretty much if you set it up, the rest is obvious.
Okay, still a little confused, but okay.
Okay, let me try again, because there've been a lot of changes here.
Okay, I'm a little
You are
confused.
telling me
Can't you
that
break
z
it up
equals
as
that.
like a multiplication, right? Like integral of 16 minus x squared times integral dx times integral of y to 0 dy.
Oh, you could split it easily. Yes, it's variable separable as well, but I don't think that's what G's issue is. Right, let me look at this fella here.
My issues are the limits of integration, so I'm not
Right.
really, I haven't been able to find those. That's where, yeah.
Okay,
So
let's look at this information, right?
okay.
What I'm looking at is, what does this thing look like if you drew it in 3D space? And in particular, what would this look like when it hits the floor? The floor is the XY plane, right? Which
Okay.
is here.
Okay.
When will this hit the floor? It hits the floor when Z is 0.
When Z is, okay, that's correct.
And when Z is 0, this becomes this information.
X is equal to plus minus 4.
And that becomes, as you said, plus or minus 4. But the first quadrant is only in this part of the world, positive x's and y's. So that means
Okay.
x equals 4. So I got the 4 and the 0 out of that.
Okay.
And then you told me y is 4. Did you tell me y is 4? You told me y is 2.
Y is 2.
And because it's in the first quadrant, it can only go from 2 to 0. And then you put that together then, that's the region D. Or R, whatever letter they're using.
Okay.
And that region, this is your f of xy. I know it only has x's in it, but it's a z function, so that counts as your f of xy as well.
Okay. 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 All right.
Right.
Okay.
Have we another homework question? Okay. So when you set this, right, when you set this up, you can choose to do it any order you like because it's rectangular. You can get away with a lot more.
Okay.
In the order that I've written it right now, I'm doing the y's before the x's, but they are separable.
Yeah.
So I could do x equals 0 to 4 of that guy. And then just do y equals 0 to 2 of 1. So I could make that, just for calculation purposes, this is a variable separable world. So that guy there is basically 2. And then this guy is whatever it is.
Yeah, that part I'm not too worried about. It's just that it's just finding
Okay.
the limits of the integration. That's where I was having a little issues. I was trying to figure it out.
Right.
So
I'm not
what I
sure
did-
if, yeah, I'm not
So what-
sure
yeah.
if Desmos would help, but you
exactly.
could
So
type in
that's what I did.
that into Desmos, but
That's
you
what I
might,
did.
you have to put that guy in as well. And that might help you see a little bit more, because Z
Okay.
equals 0 is our way of describing the XY plane, the floor, as I call it.
Okay.